Okay, this is your concept number 3, which is linear equations and graphing using slope-intercept form. So the first two parts are just telling whether something is a linear equation or not. Okay, so a linear equation, the definition is that an equation that makes a straight line when it is graphed. That's why it's called a linear equation, because it makes a line when it's graphed, so a straight line. The major rule for this is that the x and the y terms both are only raised to the first power. That's going to be a big key of this, is that they can only be raised to the first power. Okay? You also can't have anything like square roots in here, no absolute values. They just have to be a regular x and a regular y and a constant if that's there. Okay? So some examples of linear equations. Y equals 3x minus 1. Both the y and the x are both raised to just the first power. There's nothing special about this equation, so it is a linear equation. 3x minus 2y equals 7. Again, the x and the y are both raised to the first power. Right? There's no square roots, there's nothing else happening in here, so it is a linear equation as well. X equals 6 counts as a linear equation. Right? There is only an x term, which is fine. It's raised to the first power. Okay, so there doesn't have to be an x and a y term, as long as what is there is only raised to the first power. 1/2 y minus 4x equals 12. Okay, again, the y and the x are only raised to the first power, so it counts as a linear equation. It doesn't matter that this is a 1/2. You can have fractions as a coefficient, so it's 1/2 times y. That's perfectly acceptable. Then y equals -2. Again, that counts as a linear equation. There is no x term. That's fine, because the y value is simply raised to the first power, so it counts as linear. Now some non-examples. Y squared equals 5x plus 2. So because of the squared connected to the y value, it is not a linear equation. Same thing here. X squared minus y equals 10. So because the x is squared, it's no longer linear. Then in the last example, y equals the square root of x plus 3. Okay? You cannot have any square roots in your equations. So this is not a linear equation. Okay? These are all still graphable. Not that we will graph them, but you could graph them. They just won't make a straight line. Some examples of the actual lines. This is a graph that's completely done for you. It is a straight line, so it is linear. Non-example, so this is curved. It doesn't make a straight line because of that curve in it. It is not a linear equation. You could also look at charts, okay, or at tables to see if they are linear. What's important is that how much the x values are increasing or decreasing and how much the y values are increasing and decreasing. You have to check them separately. So between my first x value of a 9 to 3, it decreased by 6. Okay, so 9 decreased by 6 to get to 3. Then this 3 decreased by another 6 to get to -3. -3 minus 6 is -9. So all of the x values are being decreased by the same amount. The y values between 2 to -2 was a decrease of 4. Between -2 and -6 was another decrease of 4. -6 to -10 is another decrease of 4, so -4. Again, all of the y values are being decreased by the same amount. Okay, so because the x values are being decreased all by -6, the y values are all being decreased by 4, it is linear. Okay, so these have to be the same. Your x values have to be the same, your y values have to be decreasing or increasing by the same amount. So if I look at this next table, if I look at my x values, between 1 to 2, I'm adding 1. From 2 to 3, I'm adding 1. From 3 to 4, I'm adding 1. So my x values are all increasing by the same amount. But the y values, from 1 to 4 is 3. From 4 to 9 is 5. And then from 9 to 16, it's increasing by 7. So your y values are not all increasing by the same amount. So because of that, this is not linear. All right, now graphing using slope-intercept form. So slope-intercept form is y equals mx plus b. Now, this form is on your formula sheet that you were given in quarter 1. So if you look at that formula sheet on the left-hand side towards the bottom, they show you slope-intercept form equals y equals mx plus b. What they don't tell you is this information here. They don't tell you what m stands for, which is slope, and they don't tell you that b is your y-intercept, or where the value, or where the equation, where the line crosses the y-axis. Right? They don't tell you this information about the equation, so you need to make sure that you have this memorized. M represents your slope. B represents your y-intercept if it's in this form of y equals mx plus b. Okay, so first part here, we're just going to identify the slope and the y-intercept from the equation. So my first equation is y equals negative 4x plus 2. This is in the form of y equals mx plus b. So my m value is always the number that is connected to the x, just the number. So the number connected to the x in this case is a negative 4, so my m equals negative 4. My b value then is your constant that's at the end of the equation. In this case it's a positive 2, so my b value is 2. Now in this example I have y equals 1/3 x. Right? I don't have any constants on the end, which is okay. You're allowed to not have a constant, but when you go to list your b value, it's really a plus 0 there. Okay? So this is really, b value is 0 in this case. Your m value, which is, remember, your slope, the number connected to the x term, is in this case is a positive 1/3. All right, now identifying the slope and the y-intercept of these equations. Now, if you notice, these equations are not currently in slope-intercept form. So in order to identify the slope and the intercept, you have to first change it into slope-intercept form. So you have to rearrange this equation for y. Okay, so this goes back to what you did at the end of quarter 1 with rearranging equations. I need to rearrange this so that y is by itself. So I'm going to first subtract my 3x to the other side. So I have negative 3y equals negative 3x plus 12. Then you need to divide both sides by this negative 3. So here that's going to cancel. It's going to leave you with a 1x. Then a positive 12 divided by negative 3 is a negative 4. Now this is in slope-intercept form. Y equals 1x minus 4. Now you can actually answer the question of identifying the slope and the y-intercept. So your slope, your m value, equals 1. Your b is equal to negative 4. Second example, same situation. It's not currently in slope-intercept form, so you have to rearrange it so that this y value is isolated. So you start by subtracting x to the other side. So you have a negative x plus 6. Then you have to divide both sides by the 4 that's connected to the y. So you divide everything by 4. So you have y equals, this is going to give you a negative 1/4 x plus, this reduces to 3/2. Now remember, you need to leave everything as fractions, no changing them to decimals anymore. Now that it's in slope-intercept form, you can then identify your slope and your intercept. So your slope is a negative 1/4. That's the value that's connected to the x. And then your y-intercept is your constant. In this case, is a positive 3/2. So b equals 3/2. All right, on the back. So now we're going to actually start graphing them. So we want to graph the following equation using slope-intercept form. Step 1. Okay, so here's my initial equation. Is 2x plus y equals 3. So step 1, because it says using slope-intercept form, so you're going to have to pay attention to the directions when you go to take these tests. Okay, it tells you you have to use slope-intercept form. So my step 1 needs to be to put this into slope-intercept form. I need to isolate that y. So to do that, you subtract the 2x to the other side, which gives you y equals negative 2x plus 3. Okay, so step number 1 is just to rearrange it. Step number 2 is to do what we've been doing so far. Identify the slope and the y-intercept. So you just want to write down what is your m, what is your b value. So my m value here is a negative 2. So I have negative 2. I'm going to rewrite that as a fraction because I'm dealing with slope, and slope, when you're graphing it, you're going to need it to be a fraction. So negative 2, in order to make that a fraction, I just put it over a 1. So negative 2 over 1. My y-intercept then is a positive 3. So b equals 3. Okay. Step 3, now I'm going to actually plot this. Okay, so plot the point that corresponds to the y-intercept. Now remember, the y-intercept is where your line crosses the y-axis. Remember, your y-axis is your vertical axis. So if it crosses my y-axis at 3, that's right here, so you can plot a point. Okay, that's step number 3, is just plot that point. Now we're going to use the slope to locate at least 2 or 3 more points. Okay, you can do more than that, but you definitely need 2 or 3 points on this line in order to connect it. Okay. So now my slope was a -2 over a +1. So that means that I'm dropping 2 and I'm going to the right 1 because it's a +1. So I'm dropping 2 and going to the right 1. This line here is actually incorrect. So disregard this line. You should be dropping 2 and going to the right 1. So this next point should actually be right here, and you continue that process of dropping 2 and going to the right 1. You can also move this negative to be with the 1. So that would mean that I'm going up 2 if I have a +2, and a -1 would be left 1. You can go in both directions. So that negative can connect to the 2 or it can connect to the 1. All right, now 3x minus y equals 7. So again, first step, you need to rearrange this. So it's going to be a -y equals -3x plus 7. You have to divide both sides by this -1. So that's going to give you a +3x minus 7. Now your m is your 3. So that's the next step, is to just identify that your slope is 3 and your b value, your y-intercept, is a -7. Okay, so I'm going to start by plotting my y-intercept on my graph, which is down at -7. I now use my slope. Okay, my slope was 3, so I write that as a fraction as 3 over 1. So it's rise over run. So I'm going up 3 because it was a +3. A +1 means I'm going right 1. So there's my new point. Then you do the same process again. Up 3, right 1, there's another point. Up 3, right 1, up 3, right 1. You can keep going until you make it the whole way off the graph. You do need to make sure that you have either 2 or 3 points on this graph before you stop plotting points. The slope of the line was a +3x. So when you graph it, it should be going uphill. Okay, if you think about a person walking along this line, it should be rising. They should be walking up. When you draw your line, make sure that you connect all the points and you put arrows on the end. So use a ruler whenever you draw the lines. All right, 2 more examples following the same process. Okay, change this into y equals mx plus b form. So you get y equals -2/3 x plus 4. Your slope is a -2/3. Your y-intercept is a +4. So you plot your first point at y equals +4. Then you use your slope. So down 2, right 3. Down 2, right 3. Now remember, you can do the opposite. You can go up 2, left 3 as well. Again, your slope was negative. It was a -2/3. So from the left to the right, your line should be falling. Okay, so if you imagine a person walking on your line, they should be walking down. Same thing for the last example. X minus 4y equals 16. Solve it for y. So you have a 1/4 x minus 4. Your y-intercept is at -4. Your slope is a +1/4. So up 1, right 4. Up 1, right 4. Again, you can do the opposite and go down 1, left 4. So you have to do the complete opposite if you do that. So this is your concept number 3, which was linear equations and graphing using slope-intercept form.